On September 17, 2022, a propeller-driven aircraft crossed the Black Sea. It was not a traditional fighter jet. It was an Iranian-made Shahd 136 drone, and it was about to strike a Ukrainian power station over 1,000 kilometers from its launch point. This single event announced a new reality. A nation with no major aerospace industry had built a weapon that reshaped a modern battlefield. Over the past 3 decades, Iran has crafted a fleet of unmanned systems that now defines asymmetric warfare. These drones are not mere copies. They represent a deliberate, evolving strategy to project power, gather intelligence, and challenge technologically superior adversaries. Their use has shifted doctrines from the Persian Gulf to the Caucasus. This video will break down every major Iranian combat drone, from the first reconnaissance models of the 1980s to today's long-range loitering munitions. It will trace their technical evolution, their battlefield roles, and the specific reasons each was built. The story is one of necessity driving innovation, resulting in tools that have forced the world to take notice. Following a devastating 8-year war with Iraq, Iran's conventional military was left depleted. Its air force, once equipped with advanced American jets, faced an embargo and could not be rebuilt. A traditional arms race with richer, Western-backed rivals was impossible. This fundamental weakness became the catalyst for a different kind of arms race. Facing potential conflicts with vastly superior forces, Iranian military planners turned to a strategy of asymmetric warfare. The goal was not to match an adversary tank for tank or jet for jet, but to develop cheaper, simpler tools that could exploit their weaknesses. Drones offered a perfect solution. They could provide sorely needed aerial reconnaissance without risking a pilot. They could be produced domestically, evading international sanctions. And they could be deployed in large numbers, overwhelming expensive air defense systems through sheer quantity. This was not merely a technological choice, but a strategic necessity born from isolation and regional tension. The program began not as an offensive spear, but as a necessary eye in the sky, a way to watch hostile borders and monitor shipping lanes in the Persian Gulf. From this defensive imperative, a patient, decades-long project of innovation began, transforming a tool of survival into a weapon of strategic influence. The first major step was the Mohajer-1. Introduced in the mid-1980s, it emerged directly from the grinding trench warfare of the Iran-Iraq War. Iran needed eyes. Its traditional air force was strained, and surveillance of frontlines was costly and dangerous. The Mohajer, meaning migrant, was that solution. It was a simple piston-engine drone launched by a rail catapult. Its airframe was basic, constructed from wood and fiberglass to keep costs low and production simple. Its core specification was its function, aerial reconnaissance. It carried a camera payload to photograph Iraqi positions, flying missions that were too risky for manned aircraft. Its range was modest at around 50 kilometers, and it was recovered by parachute. The innovation was not in advanced technology, but in application. It solved an immediate tactical problem with available means. Its strength was its proof of concept. It demonstrated that Iran could field an indigenous unmanned system under combat conditions. Its limitations were clear: limited payload capacity, vulnerability to enemy air defenses, and dependence on fair weather. Operationally, it provided valuable intelligence during some of the war's most static periods. The Mohajer-1 established a principle for Iran: drones were a viable asymmetric tool. It was a humble beginning, but it laid the foundational engineering and doctrinal groundwork for everything that would follow. The Mohajer-1 provided eyes. The Ababel series would learn to strike. Introduced in the 1980s during the grinding Iran-Iraq War, the Ababel, meaning swallow, began as a simple reconnaissance tool. It addressed a critical need: to see beyond the front lines without risking pilots. Its early design was basic, a pusher-propeller airframe often launched from a rail. Its evolution marks a key transition. The Ababel T, developed in the 2000s, transformed the platform. It grew larger, with a wingspan reaching over 3 meters. Its payload capacity increased significantly. This allowed it to carry munitions. The drone could now conduct surveillance, identify a target, and then attack it directly. This multi-role capability was a major leap. The Ababel's innovation lay in its adaptability. It solved the problem of linking observation to action in a single, low-cost system. Compared to the purely reconnaissance Mohajer, the Babel-T added a potent offensive layer. Its strength was this flexibility and its reported reliability in harsh conditions. It became a workhorse. Limitations existed. Its size and propeller-driven design meant it was not fast. It could be vulnerable to modern air defenses. Its operational history, however, is extensive. It has been used by Iranian-backed forces across the Middle East for both surveillance and pinpoint strikes. The Babel proved a drone could be more than just a camera in the sky. It became a template, demonstrating that a single platform could hunt and could kill. The Babel series demonstrated a new truth. A drone could be more than just an eye in the sky, it could be a fist. This realization triggered a fundamental shift in Iranian doctrine. The military problem was clear. How could a nation with limited air power project force over long distances? How could it strike high-value targets without risking pilots or expensive aircraft? The answer emerged in a new category, the loitering munition. Often called a suicide or kamikaze drone, this is a weapon that blends surveillance with a final explosive strike. It loiters over a battlefield, finds a target, and dives into it. The first major Iranian system to embody this shift was the Babel II. While earlier versions carried small bombs, the Babel II was designed from the start as a one-way attack drone. It was smaller, cheaper, and built in large numbers. This was a move from quality to quantity, from precision tools to expendable munitions. The change was not just technological but philosophical. A reconnaissance drone returns with information. A loitering munition returns only by not returning at all. It turns the drone itself into the bullet. This doctrine accepted sacrifice for strategic effect. It allowed Iran to develop a deep strike capability without a traditional air force. The era of simply watching was over. The era of watching, waiting, and then striking had begun. The shift towards loitering munitions found its starkest expression in the Shahd 136. Introduced around 2021, this system represented a fundamental change in cost, scale, and strategic reach. It is a small, delta-wing drone powered by a simple, noisy piston engine. Its key specifications are defined by its role. With a reported range of up to 500 kilometers and a warhead weighing roughly 40 kilograms. It was engineered for one purpose: to serve as a long-range, precision-guided artillery shell. The innovation was not in complexity, but in simplicity and volume. Constructed from commercial, off-the-shelf components, each Shahd is relatively inexpensive to produce. This allowed for mass deployment. Instead of sending one high-value aircraft, Iran could launch salvos of dozens, even hundreds of these systems. They are designed to overwhelm traditional air defenses through sheer numbers, saturating radar systems and ensuring some will always get through. Its operational history has defined modern conflict. First used extensively by Russian forces in Ukraine from late 2022. The Shahd demonstrated a new kind of strategic harassment. It struck energy infrastructure, military depots, and cities far from the front lines. The drone's distinct, buzzing engine sound became an ominous signature. Its strength lies in its psychological impact and its ability to inflict sustained, long-range economic damage. Its primary limitation is its vulnerability. It is slow, flies a predictable path, and is susceptible to modern electronic warfare and gun-based air defenses when detected early. Yet by changing the calculus of cost versus defense, the Shahd 136 truly redefined the drone as a weapon of persistent, long-range attrition. If the Babel series represented versatility, and the Shahd redefined long-range strikes, Iran needed a drone with persistence. A platform that could watch, wait, and then decide. The answer was the Shahd 129. Introduced around 2012, this medium-altitude, long-endurance drone entered a category dominated by American and Israeli systems. Its role was clear: provide eyes and firepower over a battlefield for hours on end. Its core specifications defined its mission. With a wingspan of 16 meters and a length of 8 meters, it was a substantial airframe. It could fly for up to 24 hours, cruising at altitudes around 7,400 meters. Its key technology was a satellite communication link, allowing operators to control it from far beyond the horizon. This extended its effective range to over 1,700 kilometers. It was powered by a four-cylinder piston engine, a workhorse for endurance. Its primary innovation was its multi-role payload. The Shad 129 could carry up to 4 precision-guided munitions, typically sodied bombs. This transformed it from a scout into a hunter-killer. It could patrol a vast area, identify a target, and then strike it without ever leaving station. This solved a critical problem: the delay between spotting a target and engaging it with separate aircraft or artillery. Its strength was this persistent, armed reconnaissance. It gave commanders a constant, lethal presence over contested territory. Its operational history proved its value. It was used extensively in Syria from approximately 2014 onward, providing intelligence and carrying out strikes for Syrian government forces. It was also reportedly used in monitoring missions over the Persian Gulf. However, it had limitations. Its size and speed made it vulnerable to modern air defenses. Its piston engine was not stealthy, producing a distinct acoustic and infrared signature. The Shad 129 demonstrated that Iran could build and operate a sophisticated, armed male drone. It filled a gap between smaller tactical drones and the one-way attack profiles of loitering munitions. It was a system built not just for a single strike, but for sustained control of the skies. Building from the shift toward loitering munitions, Iran's program also pursued speed and survivability. This ambition materialized with the Karar, a jet-powered target and attack drone unveiled in 2010. Unlike the propeller-driven Shads, the Karar is powered by a turbojet engine. It can reach speeds reported near 560 miles per hour. Its primary stated role was as an aerial target for training air defenses. Yet its design also allows it to carry a payload for precision strikes at greater velocity. This represented a move toward faster, harder-to-intercept systems. The pursuit of speed naturally led to exploration of stealth. In 2013, Iran revealed the Sighe, or Thunderbolt, drone. Its design showed clear parallels to the captured American RQ-170 Sentinel. The Sighe features a flying wing shape, a configuration known to reduce radar signature. Its stated roles include reconnaissance and electronic warfare. Public displays of the Fatros and the larger Kaman 22 further indicate a focus on signature reduction and integrated sensor systems. These drones suggest an intent to operate in contested airspace. These projects point toward a future technological trend. The goal appears to be a blend of attributes: the endurance of the Shad 129, the range of the Shad 136, and the low observability of the Sighe. While the capabilities of these stealthier systems remain unproven in open conflict, their development signals a clear direction. Iran's drone evolution is not solely about overwhelming numbers with simpler systems. It is a parallel track seeking quality, aiming to create drones that can penetrate sophisticated defenses and return to fly again. The journey from the Mohajer 1 to the Karar reveals clear patterns. Iran's drone program began with a focus on simple, tactical reconnaissance. It was a necessary response to limited air power and vast borders. Over decades, that focus shifted decisively toward offense. The Ababel series marked the first major step, adding strike capability to a proven reconnaissance frame. This was not a random leap, it reflected a calculated doctrine. Using cheap, attritable systems to project power and complicate an adversary's defenses. The most significant technological shift arrived with the loitering munition. The Shad represents the ultimate expression of Iran's asymmetric strategy. It inverts traditional cost equations, forcing multi-million-dollar air defense systems to engage $1,000 drones. This shift from surveillance to saturation attack has redefined the battlefield. It turns quantity into a quality of its own. The parallel development of larger, more capable systems like the Shad 129 shows a dual-track approach. One track seeks swarm overwhelm, the other seeks persistent, precision engagement. This evolution demonstrates a move from import dependence to indigenous innovation. Early models often relied on foreign components or reverse engineering. Later systems like the jet-powered Karar showcase growing domestic expertise in propulsion, guidance, and airframe design. The strategic impact extends far beyond Iran's borders. These systems have been exported to proxies and allies, altering regional conflicts and providing a low-risk tool for state influence. They have proven that in modern warfare, a pervasive, low-cost aerial threat can level the playing field against technologically superior forces. The trajectory is clear. Swarms will replace single units. Autonomy will replace remote pilots. The human decision to strike will remain, but the machine's ability to identify and execute will expand. Iran's current systems, from the Shah to the Qarar, are already being adapted for this next phase. They are testing drone motherships, capable of launching smaller attack systems mid-flight. They are integrating artificial intelligence for target recognition. The drone is evolving from a single tool into a networked ecosystem. This technological march creates a new strategic equation. For decades, military power was measured in costly platforms, jets, tanks, ships. Now, a relatively inexpensive drone can threaten them all. This evens the battlefield in unexpected ways. It also lowers the threshold for conflict. A drone incursion is not the same as a manned fighter crossing a border. The rules of engagement are still being written. The ultimate implication is not just on the battlefield, but in the factory. Drone warfare is a war of production. It is a contest of numbers, cost, and rapid innovation. The nation that can build smarter, cheaper, and faster gains a decisive edge. Iran's program, born from necessity, now understands this principle perfectly. The future will be built on assembly lines. In our next breakdowns, we'll examine the electronic warfare systems designed to blind these drones, to see if the shield can ever permanently defeat the swarm.